We're gonna work on the 6.2 homework real quick. So I'll go ahead and just start this up. This section goes back to binomial experiments again and the normal approximation of binomial probabilities. So I'll go ahead and jump into the first question, which this one asks us to use a Desmos app. So there's a link here, the little click me link will pop up Desmos and it'll load a certain app that I've made, and you can respond to the questions that way. So real quickly, I am going to pull that up on my iPad. There it is. And maybe move this out of the way a little bit. Okay, so back to the questions here. A real quick comment. It says all computations needed for this activity are computed in Desmos, and it says to round any quantities to two places after the decimal. That's important. Otherwise, you're going to be getting some answers wrong. Anyway, so we're going to put our p to 0.28 and our n to 30. So let me do that real quick here. So here is 30 for n, and this is really hard to do with a finger. I'm just using a slider. I got real lucky and I was able to do that on the first try. Okay, so there's your n and your p. The rule for normality is that the np, which is mu, and the nq, which is, that's actually the mean number of failures. NP is the mean number of successes. But anyway, these both need to be at least 10. And as you can see, we have an 8.4 here. That's not big enough. So we'll go ahead and put them in. NP was 8.4. And NQ was 21.6. Like that. And does that satisfy the criteria for normality? The answer again is no, because these are supposed to be at least 10 in size. Okay, and what it's basically saying is this left tail needs to be at least 10 in length to have a nice symmetric distribution, and the right tail at least 10 in length. Then that gives the symmetry we want. We are not meeting those criteria, so I'll say no. Okay, and check our part answer. All good to go. So then there's a solution when your NP and your NQ are not big enough, and that is you can just increase your sample size. So it says increasing the sample size n will eventually allow the criteria to be satisfied, and that's always true. So, you know, a researcher picks their sample size. So here we're supposed to slide the slider for n to find the smallest value that will satisfy the criteria. So it's going to be a little tricky. But I need my NP and my NQ to go bigger than 10. So on the slider for n, I'm looking for when both of these, I'm already there. Right here, when n is 36, if you notice I have a 10.08, which is just bigger than 10, and something substantially bigger than 10 for NQ. 10.08, if I go a little lower, down to 35, I'm just going to type that in. So if I make it 35, your n times p is 9.8, which is too small. It's supposed to be 10 technically, so I'm going to delete that and make it 30. What did I say? 36? Does the trick. Okay, 10.08 and 25.92. And so it asks, what's the smallest value of n that will satisfy the criteria? And the answer is 36. Okay, I'm going to check that. Okay, and then it says a normal distribution has a skewness of 0. What give the value of this binomial distribution's skewness? Okay, so if you look down at the skewness, it's actually 0.1633 here, and but the instruction said 2 places after the decimal, so I'm just going to put that in as a 0.16. Okay, and with a positive skewness like that, that's skewed to the right. Okay, just slightly. Okay, and now the normal distribution has a kurtosis of 3. It says give the value of this binomial distribution's kurtosis. So the kurtosis is a little further down on this app, and it wants us to round it to 2 places. 2 places after the decimal. So it's 2.97 here with 2 places. So put that in. And then I would probably Yeah, so just wanted to check my answer to make sure everything was good, and it is. And now this is less than 3, so it is only very slightly platykurtic, but barely, okay? If it's a lot less than 3, then it's just really platykurtic, but that's really close. So again, slightly is a good word for this. Okay, and then it says the current distribution is very slightly skewed to the right, with the skewness was 0.16. Okay, and the next thing it says is what's the smallest sample size that would give a skewness between negative 0.10 and positive 0.10? That's between but not equal to either one of those endpoints. So once again, we're going to use the slider to answer the question. All right, so back to this. I'm hoping I'll be able to see everything. I'm looking at the skewness, and I'm going to increase my sample size until the skewness is less than 0.10, basically. So watch the skewness go down as I increase my sample size. The distribution is kind of marching off to the right. Oh, there it is. Okay, 0.10. I want it smaller than that, so I'm going slowly. Right there, I had a 0.1. Right there. Ah! That's a 0.1. And then and that's at a sample size of 97. Sorry, 96. So let me just double check that manually. At 96, I have a 0.1. And the instructions are let me move the distribution over here. Okay, so and the instructions are pretty explicit. That we are to continue sampling until the skewness is less than 0.10 or 0.1. So I'm just going to go up, instead of 96 for the sample size, I'm going to go up to 97. And now you can see here that the skewness is 0.0995, and that finally is less than 0.10. So let me go ahead and put that into my answer here. Sample size needs to be, what did I say, 97? And I'm nervous about this one, but I think I got it right. Okay, and up at top it says we got 9 out of 9, so that's the end of that problem. All right, so then I think we go on to the next question, and I don't think we're going to use this app anymore, so I'm going to go back to my white tablet and probably need a calculator. So let's go on to the next homework question. Okay, so this one, what we're going to do is use the normal distribution to approximate a binomial probability. So it says for a binomial experiment with n equal to 109, I think I'll go ahead and start writing some of this down. And p is 0.73. I guess I could go ahead and figure out q. So q is 1 minus p. So that's 1 minus 0.73. So the complement of 73% I think is 27%. Okay, and so then NP would be 109 times 0.73. And so let's do that over here. Okay, so that comes out to be 79.57. And how much rounding? It doesn't say to round it, so I'll write the whole thing down. 79.57. And you might note that this is actually the mean. So NP is the mean in a binomial experiment. So I'm going to shrink that down and put that note right here. Mu is NP. Okay, and we'll need that. But then NQ, and that's the mean number of successes. NQ is actually the mean number of failures, and we don't use that because we're only counting successes in a binomial experiment. Anyway, it's 109 times 0.27. Let's do that over here. And we get 29.43. Okay, I'm going to put both of those in. So over here in the answers, NP is 79.57 and NQ 29.43. And are the criteria satisfied? Remember, these are supposed to be at least 10, and they certainly are, so we'll say yes, the criteria are satisfied here. Okay, should be all right. And now, we're trying to find the probability that x is greater than or equal to 87. Now, the mean is about 79 or 80 here. And so I thought the best way to describe this would be actually just to kind of give you a little sketch of this. So I'm going to scroll down. I put a little histogram here. And I've got the mean of 79.57. So I'm just going to go to the largest bar and say, that's about 80. So I'm just going to say the largest bar here will be close to the mean, as close to the mean as possible. Okay, and so there's 80, and it's asking for the probability that your value of x is bigger than or equal to 87. Now, I'm not going to be real precise about where 87 goes. I just need to put it somewhere. So I'm going to put an 87 right here, and that is definitely not 7 bars over, even though it kind of should be. And what I want to do is I want to include everything to the right because it's a greater than problem. So I'm going to change the colors of all these bars, maybe to red. Hang on. And that's the, basically, let me move this over a skosh. Actually, I can move the calculator out of the way. Okay, so that's kind of the area I want. And the trick here is just to recognize that the interval doesn't really start at 87. If you're going to use a smooth bell curve for this, and I'll go ahead and superimpose one of those on here, that the interval actually starts here. So it's to the left of 87 by a distance of 0.05. So I'm going to call this to the left by a distance of 0.5. So I'm going to put this down as 86.5, just a little bit less, 1/2 less, and to the left. And that'll scoop up all of 87, okay? And then what you want to do, and by the way, there's another way to do this. If you don't want to have a whole bell curve on this, you could just do something like this. You could put the mean here. You don't even have to put the mean down, okay? The mean is 80, about 80. That's fine. You don't have to put that down. You could go 81, 82, 83, 84, 85, 86. Here's 87 right here, okay? And I need to include that bar and go to the right with the greater than probability. So to the right, including 87, and to the right goes like this. Okay, I want to include because it's greater than or equal to 87 over here. Okay, so if I want to include the whole bar, then I have to start a little to the left here. Okay, and that'll be our 86.5. Okay, so that's another way of doing it. We want to change this to x is greater than 86.5, like that, in the answers. Okay, and then I'll go ahead and check my answer here. That's fine. Now we need to give the mean for the distribution. So as a quick reminder, I'm going to come back up to my bar graph. I like that better. Okay, so the mean of my distribution we computed above. So mu, remember, is just n times p. Uh-oh. Sorry about that. Real touchy iPad. I don't know, it's weird. It kind of works really well at work, but not at home. Go explain that one. All right, the n was 109, and p is 0.73. And let me make this so you can see a little better here. How about that? Okay, and then put this back up. All right, so, and then we did the math on that. NP was 79.57. And that's about 80, and that's why I made 80 the highest bar on the graph. And then NQ we don't need. What we need is the standard deviation. So as a reminder, the formula for the standard deviation is the square root of NPQ. And somewhere we have down what Q is. I think it was 0.27. So anyway, it's the square root of N. That's 109. Times P, that's 0.73. Times Q, that's 0.27. Okay. So let's do that over here on our fancy little calculator. If I can figure out how to pull it out. There we go. So square root of 109 times 0.73 and times 0.27. Okay, so this will be our standard deviation. All right, so over here it says give the mean round to 3 places. Okay, so the mean was the 79.57, and there really aren't 3 places to round to, so we'll just go with 79.57, like that. Standard deviation, also 3 places. This time we got 4.635 for the standard deviation. Okay, let me do that again. What did I say? 4.635, is that right? Yes, it was. Okay, so okay, and then back to this. I think we can key all this in. So the mean 79.57, 4.635, and now we need the z-score of 86.5. Okay, so back down here, the z-score formula is x minus mu over sigma. Okay, so x was the 86.5. We're converting this number here, our boundary value. So we'll put in 86.5 minus the mean, which was 79.57. And then over our standard deviation, which we rounded to 3 places, 4.635. Okay, and so that came out to be, let's see here, where's my calculator? Okay, so what have I got here? Oh, you can't see it. Maybe we'll move the calculator over here for a moment. All right, so little fraction with 86.5 minus 79.57 over 4.635. Okay, and it's going to want us to round to 2 places. So we're going to have to do 1.50 for this z-score. Z-scores, we always do 2 places on those. Okay, so let's go and try 1.50 over here. And I got my eyes closed and my fingers crossed as I check. Those are all good. All right, so we're almost done. It's saying the probability that x is greater than or equal to 87 is equal to the probability that x is actually greater than 86.5. That's what we call the continuity correction here. Okay, which is the probability that z is greater than 1.50. Now, I think I'll just go to my table. I think I've got it up here. Okay, so let's put that in the 4. And we want a z-score greater than or equal to 1.50. So here's 1.5, here's 0.00. And you can see that our probability is 0.9332, but that's the area to the left. Remember, this is just areas to the left. So we want a right area because it's a greater than problem. So I can go back to our page here, and let's just do it here. So my probability that z is greater than the 1.50, which is the question we're answering at this point. If you go back up here, I circled it, but it was 0.9332, but again, I need the area to the right. So what was it, 9332? We're going to do 1 minus 0.9332 and do that on the calculator real quick. 1 minus 0.9332. And so that's a 0.0668. That should be the answer to the problem. Okay, again, eyes closed, fingers crossed. It's correct. And that's the end of that batch of problems that we're going to cover today. Good luck, everybody.